Okay, so welcome to this webinar, which we will be discussing about Kubernetes. And today we will be building a microservice. We'll be building it using Spring Boot, and we will be leveraging Kubernetes and running the microservice over Kubernetes. So be patient. Today we will be doing totally hands-on session. In the last few sessions, we covered various theoretical aspects of Kubernetes. We saw about what is physical servers, what are virtual machines. We saw about Docker or containerization. We compared each of the approach, when to choose physical servers, when to choose virtual machines, and when to choose containers. We covered Docker. We covered Docker in detail. We covered how to install Docker on your machine. We covered about how to register to Docker Hub, how to use the container registry, Docker Hub, how to create an image, how to pull an image from Docker registry, how to run containers, and how to push your images to the Docker registry. So we gave a complete walkthrough of Docker, which was a prerequisite to understand Kubernetes. In the next sessions, we covered Kubernetes. Basically, we covered the architecture of Kubernetes in detail. We covered about various operations of Kubernetes, and we covered about fundamentals of creating a pod, creating a service, creating a deployment, creating a replica set. We saw how to auto scale Kubernetes, how to auto scale containers orchestrated by Kubernetes or Kubernetes cluster. We saw how to perform various operations on our applications like rolling updates, rollbacks. We also saw how to delete Kubernetes clusters once we are done with it. So basically, we saw about features of scaling, basically the replicas, how to scale up number of replicas for containers, how to scale down. This is way of ensuring scalability. We saw about replica set and how to instruct Kubernetes to ensure that number of replicas in replica set is always running. So this is about fault tolerance. We also saw about how to ensure availability. So fault tolerance and availability of Kubernetes we covered with the help of use of replica set. We also say how to put rolling updates in deployments. So basically we covered about configurations of Kubernetes, and we covered various units of Kubernetes, the smallest unit of deployment being pod. Then pod is a collection of containers which can communicate with each other as local host, or they can share resources. Then we saw pods can be deployed using deployments, and deployments may contain the replica sets, and replica sets will manage containers. So these are all things we saw. Today we'll be developing Spring Boot application. I am using here GitHub Codespaces. I have my GitHub Codespaces set up. I did some configuration. So here, this is the dev container configuration. Basics of GitHub Codespaces, I will share you the video so that you understand. So basically, GitHub Codespaces is a feature of GitHub. Let me demonstrate quickly what it is by getting into the GitHub and then explaining you what is Codespaces. Codespaces are virtual machines. These are basically your dev environments. And in the dev environment, you can create your applications and submit the code into the repository. And you can have your ID, which is Visual Studio Code ID, running on the browser. And this is available straight upfront in GitHub. So I'm logged into GitHub. This is my GitHub landing page, the dashboard. And you see here new code space. And when you click on new code space, You have basically various templates, various repositories, which you can assign. You can also access it from the left panel and also from the plus button on the right side. So when you click on the plus button on the right side, you will be able to launch Codespaces within a repository. But if you run it from left side, here you see there are templates which are available. So if you are doing React development or Python development using Jupyter Notebook, you can select various Codespaces. Basically, the Codespaces are Docker containers which are running development environments. And this is called dev container. So this is another important term which you should be aware, dev containers. So what is a dev container? You can see the documentation. There are a site which is called dev containers.dev. So here you will find out all the dev containers which are available for you to develop any kind of application. In the dev container, you will find various templates. So available templates. Available templates are there for, say, Alpine Linux, Anaconda Python 3, Anaconda and Postgres. So there are a lot of pre-made templates which are available for you to use depending on what kind of application or microservices you are developing. You'll get a Docker in Docker container. You can get various other environments. C# environment is there. C# and MS SQL is also there. Go and Postgres is there. Java is there. Java Postgres is there. Then Node.js, JavaScript, Node.js, MongoDB. So you see here, a lot of dev containers are available. Now, Markdown, Kubernetes, local configuration, Minikube in Docker. This is also available. So there are, these are really interesting because for our session, which is focused mainly on Kubernetes local configuration, this is another dev container. Kubernetes Minikube in Docker. This is another important Docker or dev container to run Minikube. Again, you can test out all the commands of Kubernetes. And once you have successfully tested your Kubernetes cluster in local environment, you are ready to launch to Google Cloud Platform. So we'll focus mostly on the local deployment presently. And in later sessions, we'll be launching this to Google Kubernetes Service, GKS. You can use Azure Kubernetes Service. You can use AWS Kubernetes Service as well, Amazon Kubernetes service as well as per your cloud environment. The steps will be mostly the same. The interface, the UI for launching your Kubernetes cluster may vary slightly. It's very straightforward. I will share. You will learn it in the next session. So see here, there are various dev studios, dev containers for development of Ruby as well. Then you have Node.js, TypeScript, lot of other default configuration for Linux. Terraform is there. Then many dev containers, and this is list is growing. Swift dev containers also there. Dart, data science notebook, Salesforce DX project, basic Node.js. See. So you get this list of dev containers. So today what we will be interesting in is building a microservice using Spring Boot. So you see there is no such dev container available for Spring Boot. So we will create by ourselves a Spring Boot dev container. So I've set up the code space myself. What you can get is a documentation about how to run Java projects in GitHub Codespaces, right? So you see here, what I have done is I've created a Java project. You have a trial project also here available. So here you will find introduction to dev container. Basically, I'm into the docs.github.com site. So if you go to docs.github.sites, this is what you will get. Let me show you from scratch. So you have here docs.github.com. You have to go to documentation. Within documentation, you will have to go to setting up the project. So basically, there are various sections, and what we will be interested in is, let's say we are interested in code spaces. So we'll go to code spaces. In the code spaces, we will say setting up a project, and there are various other details in this setting up a project. So we are looking for adding a dev container configuration. And in this adding a dev container configuration, we want to set up a Java project. So this is for your reference. Again, I'll share this URL as well. This is for creating a Java project within code spaces. Now, I followed this instruction. You can also follow and create a code space. So you can read, and then this will make you understand how to work with code spaces. You can also work in the local environment, but I want to replicate this environment again and again. So I use the code spaces. It's very convenient. I find it very easy for me to replicate this environment. So this is my dev container configuration. This is contained within my files. There is a .dev container folder, which you can create in any of your project. And within that, you can create this file dev container.json. This will define your dev container configuration. Again, this is very self-descriptive. You can give this dev configuration a name. I'll give, say, Spring Boot 3, so that I can use it for Spring Boot configuration. Then I use an image, which is a Java image. So you can find a lot of dev containers. So basically, this is Microsoft's Docker registry. It appears to me like that. So here I see that there are so many images available. And what I used here is they have a Java image also. So let me type Java. See the results. Playwright for Java. Docker image to run Playwright for Java. Then there is Java development container images. Azure Functions Java, lot of dev container which is related to Java is coming. Few searches are coming for Java script also because of the keyword. But yes, there is Microsoft build of OpenJDK. There is also this container. For those who are wondering what is Playwright, Playwright is a tool for end-to-end testing. So it's basically tool to write in Java test cases. So you can go to any website, you can navigate inside the page, you can basically write test cases in Playwright. So this is anyway required for testers, for people who are wanting to build automation. But you see, we choose this Java dev container, and there are various releases of this container also. So you can choose this as per your images need. But yes, I have used this dev container Java. I have not specified any version. You can specify, but by default, it will take the latest version. So my image is based on the Java image, right? So they have given you some resources already in this file. For example, aka ms dev containers. This image is taking you to the same site which I shared you, which is containers.dev. So you'll see there how to put properties and what these properties mean in this particular file, which is devcontainer.json. So this is about, name is very easy name for you to remember, recall, and this will help you to remember what this def configuration is doing. So you can use a Docker file here, or you can use Docker compose file. So these are, so some documentation is also available here, how to use Docker file in this place instead of def container configuration, right? So basically what you get here is the image. You can run any image, container image. So this is from Docker registry. So I'll go to Docker Hub. So another important site which we know from our previous sessions is hub.docker.com. So as you see here, this is Docker registry. I can search for, say, Java, and what I was looking for, mcr.microsoft. Basically, yeah, let's look for this particular user, various images of Microsoft Container Registry, and you see here, let's look into what all images have been published by Microsoft, right? So you have Microsoft SQL Server, a lot of other images are there, right? So dev container template, so you can use dev container template, or you can use here the Docker file. So this is what it's talking about. If you want to know about Alpine, you can read about this Alpine, but we do not use Alpine. We are instead, we are using Java image, which will be built upon Alpine. So this is the Alpine dev configuration. So you see nothing is there except you have the image, which is the base Alpine image. So this is how the dev container configuration for Alpine is there. Similarly, I can see the dev container configuration for Java. So in this Docker project, in this GitHub project, I see all the dev containers: Alpine, Anaconda, Postgres, C++, MariaDB, then Docker existing Docker file, Docker existing Docker compose, Docker in Docker. So these are all examples which you can use. Java. So there is a Java example here. Then we can go to something called, yeah, so let's see what is there in the Java Docker dev configuration. So if I go to here, see, it's talking about the template. So hopefully this is, yes, this should be the file, which is the template. So here the ID is Java. This is so image variant, it's defining image variant. There are various image variants. There's install Maven version and platform. Right. So this is dev container template. But to see what is inside Java dev container, we go here. You see here the Java container. Read me, this file is the file. But yes, if you see here, there is a Java install Maven, install Gradle with the version, right? So that's all. But yes, let's see what is there in the Java SRC. This is the same place where we are. So I believe we'll have an Alpine Linux and then JDK. Basically, JDK installed, Maven and Gradle installed on top of a Linux image. So here we may say we want to forward 8080 port, but yes, we can do it later also. We may get some features here if we want. And one of the feature which we are using is we have Spring Boot via SDK man, right? So not too many features we need. You can keep adding it as your project grows and as you introduce more and more components. But two extensions, Visual Studio Code extensions, I'll be installing. One is the Java extension pack. Another one is a Spring Boot extension pack. So again, based on your preference, you can install some extensions, and these extensions will come pre-installed. Right, so you can uncomment this if you want to connect as a root. So this is another good feature here. So remote user is root, but yes, right now we are not a remote user. So this is about all the dev container configuration. Simple enough. Just to test my Java, if you want to verify whether Java is installed in your container or not, dev container, to be more specific, what you can do is you can run a new terminal. And then you can give Java version command to see what version of Java is installed. I have Java 21 installed here. It is JDK, Open JDK. So it shows Open JDK. Next thing is I can write a simple program also, and I can run this program also. Since I have the Java extension pack installed, I'll get this run button. I can simply run this button, click on the button to run the code. And this will run my Java class, which is simple hello world program. So this will showcase you that Java is running. Yes. You will see here the Spring Boot icon on the left side, this part. This shows that your Spring Boot installation, Spring Boot extension is also installed. So then let's start creating a microservice. So to create a Spring Boot project, you can say Spring Initializer. I think it's Spring Boot. Let me give a command again. You have to click on this Spring extension and then go to Spring Boot. I'm looking for new project. Right. So you see here, Spring Initializer, create a Maven project. So you have to remember how to get into this. I'll go inside the Spring Boot extension. So just this is important to ensure that this is installed, and then you have to type Spring Initializer, create a Maven project. This will create a new project for you. Right. So I'll demonstrate this. I have created a Spring folder inside my project so that I can build this application. Right. So I go inside this Spring project and then I choose here Spring Initializer. And I use this arrow. See, this clicking here is important. And then I say Spring Initializer. And then I say create a Maven project. So this is going to create a new Maven project. It will ask you to choose the version of Spring Boot. I choose 3.2.2. Now it's asking me to choose whether I want Java, Kotlin, or Groovy. I'll use Spring Boot with Java. Right? So let me skip this all. I will again show you how to do this. So first step is I click on Spring Boot. Okay. You can close any files if you have, because these are not required. Basically, you should open the folder where you want to create the project, choose the folder. So I want to create the project inside Spring folder in my repository. Then I click on the Spring icon, and here I'll type arrow and Spring Initializer, create a Maven project. It was recently used, so it is appearing here. Then I click on 3.2.2 because that's the latest version I want to choose for Spring Boot. Then Java. Then I can give the package name here. So package name, which I would like to use now, let me open up and set up the project accordingly. Give me a minute. I will choose some nice package names. I'll copy paste so that looks good. So what we are doing is we are creating our project for Spring Boot. So in the Spring Initializer, I will choose, maybe we are working on TinyURL. So let's keep it com.example. And I say TinyURL. Yes, I have a domain practical developer.tinyurl. So this is our project. So this is the group ID for our project, right? Then artifact. What would be the name of the artifact? So artifact name, I would say TinyURL. I can name the artifact as TinyURL. So I did choose group ID and artifact name in a Spring Boot. Basically, this is the name of the Maven project. You can change all these things. So not a big deal. But yes, using com.example, com.example.tinyurl, or in my case, com.practical. So basically what I can do is my group ID could be com.practical developer. And then my artifact could be TinyURL, right? Then I want the packaging type to be var or to be jar. Then I can choose my Java version. I'll choose Java 17. And then I can add dependencies. So here I would want some dependencies. So let me figure out what dependencies I need. I can choose Lombok. Right? This is a developer tool annotation library to reduce the boilerplate code. I can add, this is important, Spring Web. This is for creating RESTful services or RESTful application using Spring MVC. And Apache Tomcat will be the default embedded container. So this is most important component which we'll be using in our project. We will be using Spring Data JPA because we will be persisting data to the database. We can do this in H2 database or PostgreSQL or MySQL. But yes, we will have to add the appropriate driver to do this. So let's use, because these are test application, we can choose to add a driver, which we can say H2 database, right? So we can add here H2 database. Also, one more dependency. If you plan to use Postgres, then you can use the Postgres driver, right? We don't have Postgres installed. H2 is auto installable with Spring Boot. So let's stick with the H2. We can also use MySQL driver. So you have to choose the database driver in your project accordingly. But we'll go with H2. So we have 4 dependencies. And that should be sufficient for our project, right? Then workspaces and TinyURL. This is the, so we can choose here Spring Boot. So Spring, and this is the folder for creating the project. When I say OK, this will create the project. Okay, open is opening it in a new dev container. It's right launching the, we can remove this, or we can come here and we have here TinyURL, see here. So we got here. So no worries, we can look into the pom.xml. This is the pom.xml as we defined, right? It's recommending some dependency analysis extension. Okay, we can install it. No problem with that. So when you create, you can open the workspace in a separate window, or you can use the current window. So, okay, it's saying MVN version, you're not command failed. Okay, it's trying to run some MVN version. So we are inside TinyURL. MVN Spring Boot run. When you do that, it says the MVN command is not there. Okay. So MVN version is not installed in this. So no problem. We will have here MVN W, but it should have the permission. Okay. So you have to move to Spring directory. In this MVN W version, if I give, if I say ls, and within this again TinyURL, okay, and then ls, now I have MVN W. I'll choose version. So yeah, it shows there is MVN W. So if you don't have MVN in any system, you can use MVN W. So to run this project, this is a default project. I'll say MVN W Spring Boot and run. So my default project, which was the scaffolding project, which was generated from the Spring Initializer, is started to build, and it is going to run after it is downloaded, it is compiled, and then it will be deployed in a embedded container, and we can see it running. So it's still downloading all the dependencies because first time we are doing this build. Now the Spring is initialized. H2 database is also initialized. and your application is running in 8080 port. We see this port forwarding, and there is a pop-up asking to open the browser and see it. When I do this, it will show me some content, which is the default content. So we did not wrote any code here. So we just got the kind of a default page where we say that there is service not found, right? So this is by default you get when you run the Spring Initializer project. So here you see Tomcat started on port 8080. Hibernate ORM core is also started. And here you will see that there is a database will also be running here, because that will be that we also initialized in our project, right? So bootstrapping Spring data, starting TinyURL application. So let me try expand this further so that you can have a fine look into this. So starting TinyURL application using Java 21. So these all things are being displayed, no active profile. So you have a concept of profile, which is kind of different configurations you can apply. Bootstrapping Spring JPA repository, then finished Spring data repository, initialized Tomcat with port 8080, then starting our service, starting servlet engine, starting in Spring embedded web application context, and then starting our database here, H2 database, added connection to the H2 database. So all other things are related to database initialization. And then finally, we started on 8080, the Tomcat, and we got the TinyURL. So you don't have any context path here, only default path, which is blank, is there. And when you go to that default path, you get this particular output, which is coming from Spring Boot. So now after setting up, this verifies that our project is set up correctly. Next step is we define URL mapping, or you have to create your entity. Basically, no, not URL mapping. We have to create an entity for a TinyURL service, right? So what we can create, we can call this entity. So we can create a source Java file within Java folder. And we can say we will follow model view architecture design pattern. So I will create a new folder. I'll call it model, and our model will be containing a Java file, which will call URL mapping. Some better name I'm thinking of for our tiny URL table. URL mapping looks good. Some other name. I'm just trying to think, is there something better? So URL mapping could be, yes. So what we can do is we can choose one name. Name could be, I would name it, I feel URL shortcut or URL alias would be a good name rather than URL mapping. So let me rename this, yes, because URL mapping is too technical, and the Spring Boot has this special meaning for this. So that's why I'm avoiding this URL mapping. Let me call this URL alias. Or let's keep this URL mapping.java as it is, right? But yes, depending on what you feel comfortable, you can choose some different names. I don't want to get into that additional complexity. So now package, definitely we have the package com dot practical developer. Right. So you can see from the folder structure, practical developer slash TinyURL slash model. Right. So this is our package. I ignore this for time being because it's taking this Spring as the top project. Now I say import Jakarta. So let's say start creating an entity. So here I have some code, public class URL mapping. This is what we want. We will have here various fields. So we'll need the ID for this. We may need short URL. See here, these are the annotations. So we can import so let me come to pom.xml. So see what is the version of the dependencies which we are using. Right, so you have the starter data, JPA, right? Right. So this is the entity. Same for ID. And the final is generated value. Right. This defines our primary key. So our short URL can serve as an ID. Right. Then we have a long URL. So these are the two fields which we have. We can define constructors, getter and setters. Since we have the Lombok, you can use Lombok. So if you use Lombok, you have to add the Lombok dependency. So you have to check here whether Lombok is there. Yeah, we included Lombok dependency. So now in this, rather than writing getters and setters, we can say this as data. We can say create no arg constructor, and we say all args constructor. Right, and then Lombok we have to import. See, we can just do like this because there are so many objects here. Import Jakarta. Here Lombok, so Lombok starts with Lombok dot, just say star, right? So everything is there. Everything is coming in red. We have the project, which is the TinyURL, or let's rename this URL shortener. We could have renamed it URL shortener. This is the Java source path. So now when I give here, Java source path is not src. Basically here, I have this Java folder as the Java source path. Right? So this is how you will create your projects. Right? So let me do it one more time, because this will make you more clear. I will permanently delete everything, because yes, we can very quickly generate it using Spring Initializer. See, I go to Spring, I can click here, right click and say new Java project. Then I can choose here Spring Boot. Then I can choose Maven project. I can choose the latest version Spring. I can use Java. I can choose the group ID. Right? Then I can choose the name of the artifact. I will say URL shortener. Right? So this is the link. Now you can say link shortener also. That is also a good name. Or URL shortener or short. Yes, so I see. I can say link shortener. This sounds more interesting. Says not valid. So let's say then URL shortener. About this, what's the problem? So this looks too big. Let me use dev skills. Then I'll say URL. See, okay, it should be shortener, right? Something like this. I'll go with this. I'll use the jar. So in the project name, you can't use capital letters. You can use underscore for separating the words. I choose Java 21 as the version. Dependencies. I used last Lombok, Spring Boot Web, Spring Data JPA H2. So I'll use this. So workspace is Spring, right? And within this, I believe it will create package.json. And then this URL add to workspace. This is what we should do. Add to workspace. With this, I believe now we should not be getting many errors within for our Java sources. Yes. URL shortener application is there. So let me try executing it again. This we can close. And then again, I will run. This time, CD. Right. Hmm. Hmm. So now I have to run it. So CD URL shortener. Then I will choose MVN W Spring Boot Run. Now it opens. Yeah, you got the setup ready. This is fine, perfectly fine. Now, next thing which I want to do is how to ensure that these errors do not show up. Hmm, right. See, these errors are showing up again and again. Let me give one more try. I will delete this. So again, I'll go to Spring. I'll create new Java project. I'll say Maven project. I will say, no, this I have to escape again. I'll go to Spring. I say new Java project, Spring Boot initializer. That's the arch type. Maven project. It's 3.2.2 Java group ID form dot dev skills. This is the name of my channel. And group ID here, I'll say URL. Shortener, right? I'll use all small or I can say shortener, just shortener, link shortener. Tiny link. Yeah, tiny link is another name which I can go. Sounds good. Jar. Then I use maybe 17. Then I use the package Lombok Spring. And then I use the TinyURL workspace. I choose here Spring. And I say, okay, it should generate and put the code. Source initializer, I will say open. Great. So this is the new project which is opened. Here you don't get the errors, I believe, hopefully. Let's see. So we don't want to work with Git repository right now. So I'll say, or let me say yes. Let's see. Yeah, pick repository to open. You can say we can open this repository, but again, I think, let's see what happens. Yeah, nothing. Great. So repository is there. Now we are inside tiny link folder. Now I do MVN. Is this installed? No, MVN is not installed, but slash, I'll say ls, MVNW is there. We'll say MVNW, and I say tiny link. Yeah, no, sorry. We have to say we are already Spring boot run, right? So this looks better here because this project works. I close this previous window and now this Spring Boot application is running. Yes, and everything is okay. There is some build failure. Okay, there is already, this is already in use. Probably the previous application was running. So that's the reason why it is unable to run it. So we can go to the port and we can say stop this particular process. Yeah, so that let's see. Is there a way I can stop this, free up the port? So let me close this. Yes. So that should be sufficient here. Otherwise, we'll go to the process which is using that port 8080 and kill that process if this does not work. So let me run this again. Hoping, yeah, this is okay. Again, same error because the port is being used. Is it process terminated with exit code? Yes. So how to find process which is running already? So I go to Google, I will say list of ports used in Linux by processes. How to get this? The command is lsof minus I minus P minus N. lsof. Yeah, so this gives you the command. Yes. Better. I run, there is so big. So ls then 8080. I got the process. So how to kill the process? So it's a kill command, basically with followed by the process ID. So we'll say kill. PID is 89522. Sorry, 89552. Yes, now it's killed. So after doing this, let's try running the Spring Boot again. Yes, now everything is started. It is opening the port in the browser and we see this. So now we finally got the project set up properly. And now let's start creating the microservice. We got the scaffolding project for Spring Boot. Basic structure. What I mean is basic structure for Spring Boot project. Now we will create the entity class. To create an entity, we will go inside Java. We will go inside our directory. We will create a new package. So I will go to rather than Explorer. Better to have a Java project view if I could have. Yes, you have the Java. Import to view projects. You can import the projects into workspace. Yeah, you got the Java project here. This is awesome. Can close this part. We can see this project. And here you have this packages. Can come here. I can say plus. I can say yes, new package. And in the package, we have com dot dev skill dot tiny link. Then we have to say model. This is the name of the package. So this should be created here. Yes, you got this created. Now within this, I can create a class. I will create class. You can create a record also. But let's stick to the class. Name of the class. We'll say URL mapping is the name of the class. You will need some annotations here. First is it's an entity. So I got entity. Next thing is it is data because this is from the Lambok, right? So this part is fine, but yes, it's not asking me for, so no args. Yeah, it is took a while. Resolve unknown type. Let's say resolve. I will say this is in Lombok. Say quick fix. So this part it's not finding. Yes, this is the Lombok. Great. So This part is fixed. Then no args. Lombok, no args constructor. Yes. Then finally, all args constructor. Yes. So we have all these annotations in place. So no args constructor and all args constructor. These four annotations we got. Okay, because we don't had any. But yes, do not worry. We will get this fixed as we will declare here string short URL. Right, so now that is gone. Private string long URL. So we got short URL, we got long URL. Right. Now in this, we will say non-blank. Okay. You can give some message here. There is a message required in this. Is this non-blank? So here you got ID for this particular, this is the primary key. Then we will say not blank. Yes. Not blank. And then we will say, here's a message. Again, short URL cannot be blank. Long URL cannot be blank. Plus we can have some size validation. 6 message equal to so now here I have to check how to include the validation. So I've not got the validation. So let me add the validation module. So I can come here, Maven. Dependencies. I can add dependencies from this part and let's say validation and H2 validation basically. So So again, I go here. Here, Spring Boot starter validation. Yes. From the Spring Boot, I'll take this. Yes, I want to synchronize since I have added a dependency. So now this should get resolved. Size is also valid. So now I have resolved all the dependencies. So here, this is our entity class, which is URL mapping. It contains a long URL and short URL. That's it. So this is about our entity class. Now we have to create a service. This will be a post request. So what we can do is we can create a service class. So again, what I will do is I will create a package. I'll call this package as repository package. So let me come back here and I say package. I say repository package. Yeah. In this repository package, I'll create a new interface. This interface is called URL mapping repository, right? Mm. Mm. Yes. This will extend JPA repository. This is the interface for creating the mapping. Just wondering why is this error for long coming? Hmm. Yeah, this is string. Yes, absolutely. So that's something we can fix here. So this is string. So I should have here a string. Yes. So now no problem. So we got the URL mapping. Now we will create a controller. So we will again create a package. Here, go here and then say package. Package is called controller. And within the package, we will create a class. Class will be called URL shortener shortening controller. And then we'll have here auto wired. We would need here private URL service shortening service, and we call it service. So we created a service interface, but we did not create the shortening service. So let's create the URL shortening service as well before we can proceed here. So we can say quick fix, create class URL shortening service. So yes. And instead of this, we will create it in another package. We can move it to the service package. Yes. So this will have a reference to repository. So you can auto wire private URL mapping repository and repository, right? Yeah, we'll use it. So you have public short string shorten URL string long URL. Okay. Now we'll be creating controller. So in the controller, what we will have is we'll have auto wired the service. Okay. Then we have the post mapping. Right. So we'll have short URL. So short URL is the shorten. Now let's configure the application properties. So you have to create the application properties. So in application property, basically it will be in the resources. You see here, there is application properties. So we can place here the configuration. So we have the test database, org h2 driver, password. So all these details. So this completes our application. Right. So now let me close this and run this again by building it. Right. So basically, you can't test it like this directly. But yes, what the way you can test is you can go to Spring Boot. I have two services. One is here short URL, and we can say here tiny link, tiny short, endpoint mapping. So how curl minus h post minus t my URL and then this one. So now I'm adding service. Yes. I'll rebuild this project. Hoping this time it should work. Great. So this is now running. Now to test this, we can run this. We can run yeah. So you see that there is a tiny URL which is generated, right? You got the output. Now let's try this. See if the redirection happens. So go here, say like this. So finally, let me try using the Postman itself, or I can go to the ports. So let's see if we are saving it properly or not. So yes, in the service, we have to save it. Before returning, we'll say repository.save. Repository.save. Then we say you new URL mapping, short URL. Short URL is the string which we got. So this is something which we completed. We'll run it again. Okay, there is compilation error. Let me fix this. So let me not open this. I'll say read. Now open. Next is run the post. Yes. So you see here, this redirection in tiny URL service is working. So finally, we got the tiny URL service up and running. And we have implemented it. And this is the source code. In the next class, we will create a Docker image out of this. And we will install this. We'll deploy this a tiny URL service. Also, we should break this as two microservices. One is for get original URL. Other is for generate my URL, and then break it up and put this in separate containers, and you can scale accordingly. All right. So these things we will cover in next session. I'll be sharing this code in the Git repository. Wish you all the best.